Math 76, lesson 111, we're going to be talking about applications using division. All right, so the best way that I can do this is I'm just going to go into some practice problems. And what we mean by applications is how do we solve real world problems when we're using division. Okay, now this can be an issue because a lot of times we come up with remainders or decimal answers. Or sorry, not remainders, we gave those up a while ago. Remainders or fractional answers with our division problems. So let's take we'll take a simple division problem like we'll say 22, and we will divide it by 4. Okay, so the way that we would solve this, let's say I want to go for a fractional answer, right? I would say, well, 4 can't go into 2, but 4 can go into 22, and it actually fits into 22 5 times. So I put the 5, then I multiply. 5 times 4 is 20. Now I subtract, and I have 2 left over, right? But if I want a fractional answer, instead of writing remainder 2, or instead of adding a decimal for a decimal answer, what I do is I take this little 2 down here, and I'm going to write it as a fraction over the divisor. So it becomes 5 and 2/4, but then I could reduce that to 5 and 1/2, right? Okay, now let's change the parameters of this problem a little bit, because we had 22 divided by 4, right? That was the original problem. How do I divide 22 by 4 evenly? Let's change the problem just a little bit. Let's say there are 4 cars going on the school field trip. So we'll draw this out. I've got 1, or well, not cars, we'll say vans, right? There's 4 vans going on the school field trip. 2, 3, 4, right? And let's say we need to fit 22 students into the 4 vans as evenly as possible. Well, if I've got 22 students, right? That's a student times 22, meaning 22 students. I need to fit them into the 4 cars as evenly as possible. Well, obviously, all I have to do is just take 22 divided by 4. We just did that, so I can fit 5 and 1/2 students in each car. So obviously, what's going to happen is I'm going to put 5 students in each car. Then the last 2 students will cut them in half and put 1 lower half here, 1 upper half here, and then 1 kid's legs here, 1 kid's upper half here, right? No, wrong. That's not how you solve real life division problems. You can't just do 5 1/2 students. If you cut a student in half, you're going to jail. Not okay. So, how can I solve this real life division problem as evenly as possible? Dealing with this remainder of 2. Okay. So in this case, this is where using the remainder becomes a little comes in handy just a little bit. So if I go back to the original problem, 22 divided by 4, right? And I cross out the fraction because I'm not using that, because I'm not committing murder. I've got 5 remainder 2, right? So my answer is going to be 5 students with a remainder of 2 students. What I can do is I can put, I'm just going to draw a little stick people. I can put 1, 2, well, that's going to take way too long. Let's just draw. What if I just draw little heads, right? There's 5 students there. There's 1, 2, 3, 4, 5 students there. 1, 2, 3, 4, 5 students there. 1, 2, 3, 4, 5 students there. Which means that every car has 5 students, and then out here is a couple of poor 6th graders that are about to get left behind, right? Because they weren't 7th or 8th graders and they weren't cool enough to get in the car faster. And so now, how do we make sure these 2 6th graders don't get left behind? Well, it's easy. I'll just put 1 in this car. Now that car has 6, and then I'll put the other one in that car. And so now that car has 6 kids, because these are vans, right? You can fit 6 kids in a van. So now my final answer is to split them evenly across the vans. My final answer would be 2 vans with, 2 vans, let's say 2 vans of 5 and 2 vans of 6, right? And that's what we see. Here's the 6 and the 6, here's the 5 and the 5. And that's how we divide real life problems evenly. Okay, so instead of cutting our remainder into a fraction or a decimal, we're just going to disperse the remainder as evenly as possible across the objects. Okay, and this is what my final answer would be. 2 vans of 5, 2 vans of 6. Okay, now let's do an example problem from your book. Ooh, this is a good one. They tell me that 100 students are to be assigned to 3 classrooms. How many students should be in each class so that the numbers are as balanced as possible? Okay, so as balanced as possible. So what we're going to do is we're going to take our 100 students and divide them by 3. Right? So let's go to our work paper. We've got the 100 divided by 3. Whoops, the light's blinking out there. 3 goes into 10 3 times. I get 9. Subtract remainder 1. Bring down to 0. 3 goes into 10 3 times again. And I get 9. And I've got a remainder of 1. So I've got 33 remainder 1. So how do I split these 100 kids into 3 classrooms as evenly as possible? Well, one of those classrooms is going to have the remainder, right? So I can say there's going to be one class of, what's 33 plus 1? 34. 34, one class of 34, and the rest of the classes have 33, right? Or I could have written the other 2 classes have 33. There's a lot of ways we can express this idea, but that is our final answer, right? So if you guys have any questions, let me know on the school website, and I will see you in class.